Hey guys, Mr. C here, and I'm going to show you how to solve the following rational inequality. First thing you want to do is move the 1 over to the left-hand side, and the reason for that is because, as we discussed in the notes, we want one of the sides of the inequality to be 0. So when you do that, you've got 2x plus 2 over x minus 4 minus 1 greater than or equal to 0. Alright, so having 0 on the right hand side is a key element, as we're going to discuss later on. But one issue right off the bat, as soon as you move the 1 over, is there are two technically rational expressions that you're going to be subtracting. So the first one being 2x plus 2 all over x minus 4, and then the 1's technically sitting on top of a 1. So you are going to have to fiddle through with combining these two fractions, and of course one necessary ingredient is a common denominator, which the common denominator between x minus 4 and 1 is simply x minus 4. So let's go ahead and take care of that. And by that I mean we'll multiply x minus 4 to the top and bottom of the fraction 1 over 1. Alright, so we're going to go ahead and clean this up a little bit. You got 2x plus 2 all over x minus 4. And we'll be subtracting x minus 4 all over x minus 4. And that's still greater than or equal to 0. Alright, so since we do have the common denominator of x minus 4, we'll go ahead and combine this into a single fraction. So we'll just subtract the numerators. And when you subtract the numerator of x minus 4, go ahead and surround that in parentheses to distribute the negative. And that's going to be all on top of one copy of the common denominator of x minus 4. Alright, go ahead and now distribute the negative sign. So in the numerator, it's 2x plus 2 minus x plus 4 all over x minus 4, still being greater than or equal to 0. Alright, so there is quite a bit of cleanup to do here, but we'll definitely make it through. On top, we have some like terms. For instance, 2x minus x is 1x, and then the 2 plus 4 leaves us with the expression x plus 6 all over x minus 4. So when you're solving these rational inequalities, one necessary ingredient excuse me, is that the right-hand side, or a side of your choice, is 0. So you'll have to move some stuff over if none of the sides of the inequality symbol is 0. Another necessary ingredient is that, and this is kind of unique to the rational inequalities, is that when you do move something over to the other side to get a side equal to 0, you need a single solid fraction. So that's why we went through the trouble of rewriting 1 as x minus 4 or x minus 4 so that we can get a single solid fraction here. And if possible, you want your numerator to be fully factored and your denominator to be fully factored. And we're kind of in a fortunate situation here where there's no factoring that's going to happen with x plus 6, nor is there going to be any factoring with x minus 4. So once you have a single solid fraction and both numerator and denominator are factored, go ahead and box this. And that rational expression right there is going to serve as our f of x. So then what we do is move on to find the zeros of this rational function. And the quick way of finding the 0 of this rational function is to take the numerator expression and set that equal to 0. So x plus 6 equals 0. Go ahead and solve for x to get x equals negative 6. And that's the 0. And another thing that you want to consider with rational inequalities are any instances of vertical asymptotes. So let's see if this rational inequality has a vertical asymptote. And the way to find that out is to take the denominator of the rational expression, set it equal to 0, and solve for x. So the denominator of the rational function is x minus 4. And it looks like when x is 4, we get division by 0. And as we discussed in class, that's going to create a vertical asymptote in our graph. So what we do after this excuse me, is take the zeros that we found from our rational function, in this case there's just one, as well as the vertical asymptotes, and again in this case there's just one vertical asymptote. And what we do is we plot both of those values on the number line. Alright, so I'm going to sketch up a number line and place negative 6 on it, and also place positive 4. So since positive 4 is a vertical asymptote, or in other words, a place where division by 0 occurs for the function, I immediately just put an x on top of it. And the reason for that is because regardless of the inequality symbol, whether it has a bar or not, we're not going to include positive 4 as part of our solution set. All right, and that's because positive 4 is where division by 0 occurs, or in other words, a vertical asymptote. So once you have the zeros and the vertical asymptotes of the rational function on your number line, what you want to do is execute the method of test points. All right, so with the values of -6 and positive 4 plotted on the number line, you can see there are 3 sections. And basically, test point says take a number from any of these sections of the number line and try it out. And by that I mean plug it into the function and see whether or not the output is a positive value or a negative value. So I'm going to start with this piece that's to the left of -6. I'm going to go ahead and pick a number that's less than -6, maybe -7, and I'm going to plug that into the function. And the function that we'll be using for this is what we have boxed right here. And that's pretty much why I box it, is so that it's easy to reference and refer back to. All right, so with -7 as a random value from this part of the number line, we would have, when plugged in, -7 plus 6 all over -7 minus 4. And simplifying top and bottom separately, before we reduce the fraction, we're going to have -1 over -11. And two negatives, when you're dividing them, will come out to be a positive. So positive 1/11. And the important thing about this value is that it's positive. The method of test points would therefore come up or give us the conclusion that no matter what value of x you choose, so long as it's less than -6, it's going to make the function positive. So I'm going to indicate that all these numbers from this part of the number line make the function positive. So we move on to the next section, picking a number between -6 and 4. I think I'm going to go ahead and roll with 0. We plug that into the function, we're going to have 0 plus 6 all over 0 minus 4. All right, so that winds up being 6 over -4, and looks like there's a GCF between those two. This will reduce to -3/2. And the important thing about this number is that it's a negative number. And the method of test points would therefore tell us that any number that's between -6 and positive 4 is going to make the function negative. So I'm going to put a bunch of negative signs on that part of the number line. All right, last but not least, we'll pick a number that's greater than positive 4, maybe 5, and plug that into our rational function. And that's going to leave us with 5 plus 6 on top and 5 minus 4 on bottom. That, of course, gives us 11 over 1, which is 11. And the important thing about this value, not so much the digits, but the fact that it came out to be a positive value, meaning that any number that is larger than 4 will make this function positive. So we're about ready to answer this rational inequality. First, you have to decide which parts of the number line you want to keep. Do you want the positive parts or the negative parts? And what's going to help you with that decision is the inequality symbol that was retained throughout all of our steps of algebra, and that inequality symbol is greater than or equal to 0, meaning that we want all the x values that make this function positive. All right, so going back down and looking at the number line, let's go ahead and start to form our answer, and we'll use interval notation for it, of course. We want to keep all the values that are going from -infinity all the way up to -6. So parentheses -infinity, comma -6. And because there is a bar underneath the inequality symbol and -6 is a 0 instead of a vertical asymptote, we are going to want to include this as part of our solution or as part of our answer. So what that means is we'll bracket the -6, and then we're going to union, and we're not going to bracket the 4 because this is an instance of where division by 0 occurs. So again, even though there's a bar underneath the inequality symbol, the fact that 4 is not in the domain of the function at all means that we really shouldn't be keeping it as part of our answer. So because of that technicality, we're going to use a parenthesis and say 4 comma positive infinity. And that's the answer to this rational inequality. I hope you find this video helpful. If you have any questions, feel free to contact me. Otherwise, thanks for watching.